All right. So we went down this list. Do we talk about the web languages? Okay, so we talked, yeah, so we talked about how all these different technologies are kind of all the same. You know, they just are, you know, this is original language for web. This is the upgrade to that. This is the sort of kind of upgrade to that. This is kind of the new kid. There's then over here, these are all JavaScript technologies. Okay, these are literally all JavaScript, not even upgrades, just JavaScript libraries, and just JavaScript. All right, so then kind of the thing that's most important to us is over here, we went from procedural to object-oriented languages. Did we talk about the difference there? Yeah. So I probably gave you the example of like a telephone, the procedural telephone, pile of wires versus thing that looks like a telephone. Okay. C++ empowers programmers to make bad decisions. I probably used the example like if you're inviting me to a party, you would hand me the house instead of the address to the house, and in real life it would never make sense to hand me the address. So in comes Java, which introduced the idea of a virtual machine, but also took the special syntax for memory away from the programmers. So we don't have things called pointers in Java because whether something is passed by address or passed by value is taken care of for us. Let's actually, while I'm doing that, have we actually talked about Swift yet? Or is that kind of where we left off? Okay. Let me just, okay. I want to just insert a slide here. We're going to call this guy variable passing. So let's just give some syntax, well, I guess some definitions related to that idea of passing giving me the house or giving me the address of the house, okay? So we have two ways that variables can be passed. We can pass by value, we can pass by address. Sometimes this is called pass by reference, okay? Pass by value, let's do it this way, says that a copy of the value is passed into the method. This guy has no side effect. So any changes we make to it live and die in that method because we got a copy. If I hand you a quarter, let's say I had 2 quarters in my pocket, I hand you one of them and you go and melt it down or something. That does not impact the quarter I still have in my pocket because I gave you a copy. That makes sense? But if I hand you my house and you start spray painting the garage, I'm going to see a spray painted garage when I get home, right? So that's passed by address, passed by reference. So this is a pointer, here, let's call it a memory address, which is referred to as a pointer, is passed, which leads to the original value. There is side effect. Okay, so if I tell you my address of my house and you scoot over there during one of our breaks and spray paint my garage, when I get home tonight, I'm going to be in for a surprise, right? He didn't get a copy. He went to my actual house. I gave him the address of the house. All right, so that's the difference between passing something by address and passing something by value. That makes some sense? Okay, and we'll see some examples, but again, we're trying to kind of compress the 535 stuff in here. Okay, so Java kind of came in and took a lot of this decision making away from us. Now, with that in mind, things are still passed by value or passed by address. We just don't get to control that. Okay, we still have to deal with it. So, for instance, we're going to talk about arrays today, which you know what they are, but you're going to know a lot more about them when I'm done with you. I go into a lot of detail about arrays. But in any case, we're going to be talking about arrays, and in Java, arrays are passed by address. So if I pass an array into a method, if we make changes to that array, we're making changes to the actual array, not a copy of it. So an array is passed to a method in Java similarly to me giving you the address to my house. Okay, you run over there and spray paint it, I'm going to see it when I get home. Make sense? All right. And we don't get to choose that about arrays in Java. We don't get to say, oh, I'm going to pass this one by address, I'm going to pass this one by value. In C++, you could. You could choose which of those you wanted. In Java, it's always passed by address. Always, always, always passed by address. Now, if we had an integer, a primitive type in Java, those are always passed by value in Java.
Is that why they were saying like we don't use linked list in C and C++ because there is some segmentation issues?
No, you would use linked list in there.
They were saying it is still you have to take a lot more precautions to use a linked list in C and C++.
Well, that's true. I mean, you need to take more precautions because in C and C++ you are in charge of memory. So when you create a new node for a linked list, you are requesting memory for that. And then you're also in charge of cleaning up your mess. Okay, in Java, we're not in charge of cleaning up our mess. Okay, it's just like at my house. You know, when I cook a bunch of food at my house, I just leave the mess laying around, okay, and it magically cleans itself up. Yeah, 16 years. It's worked that way for 16 years. Sometimes I get a little feedback about that, but my laundry gets done as well. Magically. I mean, it's like a Roomba. You know.
Yeah, it is really the life after.
Yeah, I mean, you know what a Roomba is, right?
No.
The little robotic vacuum cleaner. The little circle thing that you put in your house and it knows how to not bump into walls and stuff like that, and it vacuums the house.
Yeah.
Yeah, I mean, mine's a knockoff model. It's the name of it's is Tabitha. That's my wife's name.
Say it in front of them, then we are dead.
No, I would say it in front of her. My wife's pretty cool. You have to assume that if you've been married to me for that long, you have to have a pretty decent sense of humor. She's a lot more serious than I am, but she's pretty used to she's used to the shtick.
She's hearing it from 17 years now.
That's right. Yeah, it's in one ear and out the other. All right, so this is just the high level thing of variable passing. In a language like Java, we don't get to choose. It's the decision is made for us, which then means we have the extra kind of responsibility for knowing. We have to know that if one of the primitive types is passed in, like an int, a char, we'll talk about those briefly here in a few minutes.
What we can use the reference value and create a local variable and make changes to that local variable after assigning that reference value. I mean,
I get what you're saying. So if I pass in an array by reference,
yes.
let's just look at some code real quick. Why don't we just do that? So you want to do something like this. Let me kill this. Kill this. Here, I'll just create a project in here. We're going to end up going over to Android Studio in a few minutes, but this will just be quicker for right now, if that's cool. CSC, what's 37? Fall to 2016. It sucks getting old. Start forgetting what year it is. All right. All right, so I'm just going to create a quick little method here. We'll call this guy static void change array. Okay, we'll have this guy taking an int array AR as a parameter. We'll go ahead and define an int array AR is equal to 1, 2, 3. Okay, well, so let's play it out this way. I'm going to say AR at bucket 1 is equal to a -7. Then let me just do a quick static void print array, int array. What's up?
You're so fast.
I've been doing this. I've been doing this for a couple of minutes.
I get worried even when I write and it gets read. I say, oh my god.
I've been programming since I was 9.
Yeah,
So, yeah, I can code significantly faster than I can write. So I slow down for you guys. I talk usually while I'm doing it. So let's just do a driver dot print array. We'll pass it AR. Then we'll say driver dot change array. Pass that AR. Then we'll say driver dot print array. Passing it AR. All right, so I defined an array initially. It has 1, 2, and 3 in it. So this is an array literal. Just fill it up with 1, 2, and 3. We'll go ahead and print out 1, 2, and 3. So this is going to do a 1 followed by, this is how you represent a tab character. So 1, kind of a big space, 2, big space, 3. And then this will kick it down a line because I'm using a print here instead of a println. Okay, so this will kick it down a line just to give me a carriage return. Then I'm going to call this change array guy here. This takes in an integer array, but since it's an array, that guy's passed by reference. All right, so a pointer to AR is passed in. When I make a change to bucket 1 of AR, I'm making a global change here. Okay, which means that when I print it out a second time, it's going to be 1, -7, 3. All right, so let's go ahead and run that. There's my 1, 2, 3. There's my 1, -7, 3. All right, so now what you want to do is you want to do something like this. Int array AR2 is equal to AR. And then you want to just change AR2. Like that. Okay, so my output's going to be different.
yes, it will be.
Okay, output's the same.
No, output will be the same because there is no change in the global variable because we are changing the local variable, which is AR2. And we are not displaying AR2. We are displaying AR of 5.
There's AR. There's AR. I printed the same thing twice.
But we are not changing the global variable. Right?
I did. It changed.
But that's in AR2.
You thought it was in AR2.
There is no copy for AR2.
But right here, here's AR. It was changed, wasn't it? Evidence suggests that it did change, correct? You want to know, now you want to know why, right? Okay, I'll show you. First, let me do it this way. I'm going to say system.out.println AR here. We're going to say system.out.println AR there. And I'm going to say system.out.println AR2. All right. What's going to display right here?
1, 2, 3.
Okay. Nope.
Just 1.
It's going to be a memory address.
Oh, you didn't got the solution.
Yep. So usually you would create an array like this. And then I might say AR at bucket 0 is equal to 1. AR at bucket 1 is equal to 2. AR at bucket 2 is equal to 3. Something like that. Okay. What's this guy? What did tell me in 535? What did you learn about the new keyword? What's that guy do? This guy would be the constructor for building our array, but specifically that guy. What's that guy do? What can you tell me about the new keyword?
An operator that allocates memory.
Yep. So the way I like to explain it is I say it's like our real estate agent.
Okay.
All right. So the new keyword is the person that works on our behalf with the operating system to go out and find us a plot of land big enough to hold this dude. Okay? I'm going to talk about more details about how that array is built here in a few minutes, but that's what this dude does. So whenever you see the new keyword, it always brings back a memory address. Okay? If I hire a real estate agent in real life, and I say, hey, you know, I'm looking to buy a house or I'm looking to build a house and I want the house to be this big. Find me a plot of land big enough for that. When the real estate agent comes back, she doesn't bring the land with her, right? She's not, You know, she gives me the address of where I can go and check out the land. She always comes back with a memory address. So this guy will print out a weird looking memory address which points to my array 1, 2, and 3. Okay? Then,
What we create a global variable, would that change too?
what if we, well, this is a global variable as far as we're concerned here because we're passing it around. We're never returning that value. We're passing in the array and making changes to the array. So it effectively is global here. Let me show you a quick picture. I'm going to show you the punchline here.
Something like C in my mind, so
Oh, but it's the same. Yeah, it's the same as C. We're just not using the special syntax for pointers because it doesn't exist in Java. So here, let me do this. We'll draw a picture. So we have our int array AR. All right, so understand that what I have written right there is what I like to refer to as syntactic sugar. Syntactic sugar for that. It's a quick way of defining an array that already has some stuff in it. All right? So instead of me defining the array and then filling it with a couple of things, this allows me to quickly give me an array with some stuff. Make sense? All right, so I call this syntactic sugar because Java's doing some of the heavy lifting for me behind the scenes. Okay, it's it's doing all those lines for me so I didn't have to write them. Now, not that often will we do something like this because usually we're creating arrays to store crap. So we kind of create an array big enough to hold 100 things, and then while the program's running, we start filling it up with stuff. All right, we don't necessarily have the initial stuff to put in there, but for this example, we do. All right, so I have a variable here called AR. And just to keep things simple, we're going to say AR, trust me, the memory address is significantly scarier than just 10 or just 100, but that's what our value is going to be here for AR. Okay, then we had our, doesn't matter which, actually what do we do it? Change array. We had our change array method that took in an int array AR. And actually, just for the sake of argument here, just so we can keep these things separate, I'm going to call this guy AR2, and I'll call this guy AR3. Okay? Just so this guy and this guy don't match. The names of them don't match. It'll help me illustrate what I'm about to show you. Okay? Nothing's changed in terms of logic at this point. This program will do identically to what it just did a second ago. So this guy actually took in a variable called AR2. And we called this guy from up here. So, you know, we did something like driver.change array, passing it AR, which called this method down here, passing AR in for AR2. So we have a variable down here named AR2 with the exact same address. Okay? Then you had me create a variable called AR3. And you had me set AR3 equal to AR2. Well, what's the value of AR2? Same address. All of these guys point. So we have an array that lives up here in, I'll just actually start by drawing it the right way.
Oh, got the idea. Every time it's reference, no matter what. So we have to be very careful every time we change the value.
When you're passing something by reference, you do. All right, and make those guys orange. Okay, so each of these guys is said to point to this place in memory. Make sense?
Yes.
They all point to the same place. Okay, so we have different names, okay, but they all go to the exact same place. All of them are referencing the same thing. Now, to accomplish what you wanted to do, if you want to force a copy of the array, you could do something like this. You can say, oh, let me do an AR2 here. Well, let me just prove it to you real quick. So we'll see that every single time we print stuff, I'll dump the two print arrays here. So we define our array AR, we'll print out a memory address. Then we're calling change array. We print out the memory address. Then we actually change it, but I'm not printing it out again. But here's AR3, we print out the memory address. So this program should show three things, and they should all be the same value. All right, so there's our proof that they're the same identical memory addresses. Make sense? Okay, now if you wanted to make a copy, then what you would do is, well, here, I'll just do it in place here for a second. So we're going to say int array AR3 is a new int array of size AR2.length. So it's going to be the same size as AR2. But there you go. You see our real estate agent there that says, go get me a new memory address. Okay? And then I'll go ahead and I'll say, for int I is equal to 0, I is less than AR2.length or AR3.length. They're the same value. I plus AR3 at bucket I is equal to AR2 at bucket I. All right. Now when I print out AR3, it'll be a different address. When I change AR3, I'm changing that local copy, not the original. Make sense? So now you'll see two identical addresses and one different address. There's AR3. Okay, so now when I go and actually do our printouts, you'll see that I did change AR3 in here, but it did not have a global impact because I changed a copy.
So that AR3 which is created locally in change array can be accessed in the...
No, because its scope is local to that function. So it died at the end of that function. We brought it into existence, it had a hope, and then poof, the method ended, out of commission. That makes sense? Realistically speaking, I mean, there might be some scenarios where you might do something like this, but generally speaking, your problem solving will revolve around, hey, I have an array, I need to be careful about what I change in this guy because changes are permanent. So typically the problems you'll solve with arrays are problems where you want it to be the one thing that you're manipulating. So, don't view this as a limitation. View this as a fact about something that's a powerful tool that we use. We just have to be aware that changes are permanent. So we need to make sure that we don't lose data or something like that. All right, that makes some sense? Okay. Well, this one's caffeine free. We're screwed. This one's full lead, but all right, what was I doing? Oh yeah, that's right. I'm going to come back and tell you what this means here in a few minutes. Super important, especially as we start talking about linked lists. So with Java, one thing that I don't like that a lot of textbooks say in Java, which is why I typically don't use a textbook for a Java class, although I do use them now, but since you didn't have me for 535, which scrap it, we'll just roll. But I started using one. But in any case, a lot of Java textbooks say that pointers don't exist in Java. All right. So I might ask the question, what's the definition of a pointer? You guys heard of pointers before? Sounds like you said you've done some C and C++? Okay, what's a pointer? If you had to define a pointer for me, what would you say?
Pointer is a reference value reference variable which stores address for other variable.
Yeah, I like that. So I would probably summarize it kind of in the way I'm going to teach variables here. It's a primitive type variable capable of holding a memory address. But what you said is equivalent. It's the same thing. All right. So that's what a pointer is. Now, a lot of textbooks say pointers don't exist in Java. Do you agree with that?
No, they're all pointers. I mean, they're all memory addresses.
What is that? That looks a lot like a memory addressy thing to me, right? Okay, they exist. We just don't have a specific syntax for working with them. That's what was taken away from us in Java. Okay, and most of the time that helps us, but it was actually reintroduced, and it looked like I think I mentioned that last time. In C#, I didn't. We just started talking about C#, it looks like. So Java and C# are pretty similar. In fact, actually, initially, Microsoft stole Java. They had a language called J#. That was Java syntax using Visual Studio, Microsoft's version of Android Studio or Eclipse for doing this stuff. And it was good. There was nothing wrong with it. But Sun Microsystems sued them. They lost the lawsuit, blah, blah, blah. Microsoft came out with C#. The languages are very, very, very similar. The one thing we talked about last time is there is one advantage of C# is that there's a performance advantage is the true advantage from a consumer today, and that is when you first compile a C# program, it compiles down to Microsoft Intermediate Language, this missile code, which then the very first time you run it, it uses a just-in-time compiler to become a native
It's like
program.
producing a cached copy of what you're executing.
Only the first time. From that point on, it's always native. It's a true program for Windows.
So when we have too much memory filled up with that images, so we need to delete them, right? And again,
Well, I mean, you're not talking about ridiculous amount of memory. I mean, you're just, if we're going to keep it simple, we might say maybe the footprint doubles in size the very first time you run it, but then it's always that size. Because initially you have, here's your lines of code that are capable of running in the .NET component architecture, which is like the Java virtual machine. After you run it for the very first time, now it's twice as much code because now it's made for running right on the CPU, natively, fast. So that's a perk. Although they say it's platform independent, but it's only platform independent if you have .NET. All right. But what C# also brought back to the table is they recognized, so if we come back in here, still stick with C# here, these guys reintroduced the idea of, I think pointers is fine, by allowing a memory-specific syntax within unsafe code blocks. So C# basically said, hey, look, if you want to use your old C and C++ style pointer stuff with the asterisks and the ampersands, fine. You just have to put it inside of a code block labeled as unsafe so that you're proving to us that you're aware that you're playing with dangerous things. Okay, so you're allowed to do it, but you have to prove that you're doing something bad. Because remember back here, we said that one of the problems with C++ is it empowered programmers to make bad decisions. Okay, we can just willy-nilly manipulate memory, and we might be doing it for a good reason, but more than likely we were doing it because we didn't know what we were doing. Is probably the issue. All right, that makes some sense?
unsafe code blocks in the sense.
It looks like this. So for instance, you might have something that says unsafe, opening curly brace, int, well here, let me just do it as a text field because that'll be easier for me to type. Because then I can left justify it. something like that. So you can use old C and C++ pointer syntax as long as you're doing it inside of an unsafe code block. So this says define an integer named A, set it equal to 5, define a variable B that is a variable built for holding an integer address, an integer pointer, and store in there the address of A.
You don't have that in Java.
That doesn't exist in Java. Yeah, that's what we lost. In Java, the books say pointers don't exist. The reality is we just lost this special syntax, that piece, and that piece. Okay, we don't have the ability to work with those two things to get the value at a memory address or get the memory address at a, of something. We don't have that flexibility in Java. Make some sense? All right. And the reality is rarely do you need something like this. But every now and then it's helpful. And Java took that away. We didn't have that ability to directly manipulate it. So it's one of those, way less than 1% of the time, Java's a little bit of a headache because they've removed this tool. But the rest of the 99.7% of the time, Java protects us from ourselves. It's kind of the punchline. Go ahead.
Take it by chance. I was saying if it is in Java, then it will be in C# too, because they will be updating from C and C.
Well, right. So Java took it away. C# brought it back.
Oh, C#.
But they brought it back
As
with a
unsafe.
caveat. Yeah, they said, look, you can have your syntax, but you got to tell us you're being, you realize you're potentially being unsafe. Oh, it was online too.
We should have bet it on.
Oh, I was into a wind.
We should have bet on it. It was pretty cool.
It was right online. Man. What was I talking about? Oh, okay. So let's go back to this chart here. So we've been kind of walking down this path here, right? We went from C to C++ to Java to C#. And then way down here we have we have Swift, the newest, coolest language by Apple. Apple made it, must be good, right? I mean, we love Apple, don't we?
No. It's
But-
not be there.
Okay, what's up?
Maybe you not be.
But, well, hold on, but I mean, they made Swift. It's the most modern language we have. It must be awesome, right?
I recall that you told me that there is only small difference between ObjectiveC and Swift.
Oh, no, that's not even close to true. Oh, not even close to true. Here, let me show you. ObjectiveC sample code. So I'll show you what ObjectiveC looks like. ObjectiveC is very verbose. Let's see if we can find well, here, let me just write something for you. So let's say that we're writing a class. Let me left justify this. All right. So let's say in Objective-C we have a class called player. All right. And we're going to say that player, let's see, it's this. And we're going to have a string name. Actually, it's string player name, and we're going to have an int jersey number, something like that. Then we'll have ID init with name. And jersey number. Actually, I'm going to say that. Jersey number JN. Shrink this down a little bit here. self is equal to super init return self. Name is equal to n. Jersey number is equal to jn. Something like that. Then if we're going to actually create a player, so this is the player class, so let's say someplace else we're actually going to create an instance of player, we would say player pointer p is equal to player Alec init with name Mike and jersey number 5. Okay, so a lot of square bracket stuff. So this doesn't look anything. I mean, C++. Well, Java looks like C++. C# looks like Java. This does not look like any of those. It's similar enough with like int jersey number and that kind of stuff, but the actual structure of the language, this uses something called message passing. So instead of a dot notation, it uses message passing. If I was doing this in Java, the equivalent line, or in the equivalent line here in Swift, let's say, would be player P is equal to player Mike 5. These two lines are equivalent to each other.
That's Swift.
Swift is the bottom one.
That's similar to Java.
Yep, Java would look like this. Player P is equal to new player Mike 5. And C# would look like that as well. C would look like player pointer P is equal to new player Mike 5. So this is C++. Because if I just said player P, which is allowed, now what am I doing is I'm storing inside of P the actual player, not the address of it. All right. How would this look in C? Ah, tell me about that. It was a trick question. You might be smarter than I thought. No, that was true. I really thought you were an idiot. Exactly. Yeah, C is not an object-oriented language. So we would have had to do like an array or something like that if we want to store multiple pieces of crap. Yeah, or a struct. Yeah, and C would have been structs. Yeah, structs predated our objects, right? I can tell the caffeine's not in there. I'm missing it.
I can get the one more.
What's up?
Diet Coke, everything that's done is not good.
Like it's not good for you or doesn't taste good?
It doesn't taste good.
Yeah, I mean, I think Diet Mountain Dew is one of the better ones. Diet Dr. Pepper is pretty good. Coke Zero is good. Yeah, those are all.
Like 5%.
Well, no, and I get it. I would probably prefer that as well, but I drink a lot of soda. I'd rather die from whatever that's going to give me than the calorie intake from that because I'm already big enough. What's up?
Maybe you can get cases if you continue to have high fructose in your salt-based line.
No, I think the amount of soda I drink in a given, I would take in like 10,000 calories in soda a day. I probably drink, I don't know, probably 4 liters of soda a day.
Really?
At least 2 liters of soda a day.
Today I thought like I was gonna buy a can of Mountain Dew and I was like, oh, I just drank some soda 3 days ago. No, it's too much.
That can's already half gone. I just opened it. Yeah, so I'm pretty certain the fake sweetener is poisoning me, but
But they were saying
sugar I know I'll gain weight from.
They were saying even Diet Coke doesn't. It has a calorie value something. It's like how, but they
Well,
were like
Diet
the
Coke,
videos,
it's
they
like
show.
less than 1 calorie.
I know that, but they were showing it is still affecting your body. It's still.
Yeah, because your body reacts to the sweetness of it, even though it's fake sweetener. Yeah, your body reacts to it and makes you crave more sweet.
Yeah, that is what.
So I just find that if I crave sweet, I just drink more diet soda.
I usually make lemon water and put some spoons of sugar and lemon and water, and it tastes the same.
It doesn't have bubbles in it though.
We can carbonate it. We can carbonate it and.
No, I'm down, but somebody's got to make it for me.
Yeah,
We already talked about that.
Maybe you could just place some glass and lemon and some magic could happen.
Yeah. Yeah.
It is magic.
You would hope. There's this stuff called emergency. You take like as like a preventative for getting sick. It's like a powder you put into like water, and it's called emergency. It's like supposed to be really high vitamin C. It's supposed to kind of help you not get sick. I usually take it pretty commonly near the beginning of semesters. You know, when students are coming back from wherever they've been for the last 3 months, because professors tend to get sick then. Right? During the school year, I'm used to, I'm bombarded by everything, so I have a pretty decent, immune system, I guess. But right at the beginning, I take that. Well, my wife's in charge of making me the emergency. You put the packet into the water, you mix it, and so if I don't take it, that's on her. That's her fault.
She'll be like, one day I'm done.
No, see, she's only 5'4". She needs me to reach tall things. The other day, I had to install a light bulb. That would have been impossible for her to do.
I think you build your house higher for
That's right. Keep the ceilings high. There's more truth to that than it should be. I'm also in charge of like killing bugs, like big spiders. She's scared of big spiders or bees, like wasps and stuff. Yeah, I'm like the enforcer.
What do you do?
Smush them.
You made it sound like you're some kind of.
For her, I'm like a superhero because she's terrified of them. She starts flipping out if there's a bee in the house or something. Well, I'll just slap it. And the worst is like when there's spiders on the ceiling. If you see a little spider on the ceiling. Because now she's got to get up high, and she's afraid of it. Or I could just stand there and just pinch it off.
Even thinking of that makes me.
Oh, you're afraid of spiders?
Yeah. They make you scratch when they come on the door. Didn't happen?
What?
Like when some spider gets rubbed on your skin, they get infected.
Well, if they bite you?
No, just sometimes we be in a hurry and we just do like this, and they're.
You mean allergy or some kind of?
Yeah, maybe you have an allergy to it.
I think you have. If they bite in the night, maybe there is like a little bit that redness.
Yeah.
Yeah, I get that.
It might have some kind of like a scratching or irritation.
I first thought I could be Spider-Man, but no.
You could be Spider-Man.
It was just scratching.
So see, she cleans up after me, and I kill the dangerous, scary things.
So you're equal.
Yeah. She's also afraid of big dogs.
So you got a dog there?
No, I don't, but whenever there's a dog outside, I protect her.
Dogs shouldn't do that.
That's got to be a big dog. If the dog's too big for me to handle it, that's a big dog.
You got cats?
We had cats. Yeah, our last 2 cats we had to put to sleep 10 months ago or so. Been almost a year. So now we're empty nesters. No cats. Yeah, they were like sick. They were old. So before they got too sick, we had them put down, put to sleep before they started suffering. So, but we had cats for 15 years.
Wow.
16 years.
Happened last year when you put the stuff on Slack too.
Well, yeah, we had our other cat we had put to sleep a couple of years ago. And then we were down we had 3, then we were down to 2, and then the 2 were sisters.
So I think you didn't get any more because it hurts when they fall.
Oh, I mean, there's truth to that, but also, I mean, there's also a level of freedom when you
Oh,
don't have them. Because, we can only go away for 10 days at a time or something like that. Because, my wife would be concerned what the cats would be peeing on or something. Or, you don't have cats.
It's fun.
Yeah, I mean, there's.
Seriously, for the pets, it is really. And in this country, in India, we are not even, we put them and there is no legal or anything, if something even happen. But here you have to take really care of that if there is like some.
Mm-hmm. Well, they become part of your family, though. We had the cats since they were little. They were kittens.
Yeah, they are so.
So we,
cute, they are small.
we raised them.
yeah.
But it does make you place bound. We couldn't really go on a trip anywhere longer than 10 days. Even though we had friends who would come over and check on the cats and feed them and stuff like that, our cats would miss us, and then they would.
I had 2 cats. They were all very intelligent.
Mm-hmm.
I kind of slapped them and told them to be there, and the rest of the life they feed there.
Well, we didn't have problems with our cats in general, but it was always that fear, because early on we had another cat that used to pee on stuff, so my wife was always
It's just
paranoid that they were going to start peeing on stuff.
and they stink a lot when they pee on stuff.
Yeah. Oh, trust me. I can't smell it, but I had to get rid of furniture. I've had to put new flooring in the whole house.
You need to clean up all that, and it doesn't go.
Yeah.
It's fine.
Yeah, my wife would like you. Totally agrees with you. For mine, I don't smell it.
Really?
Yeah.
I can't smell it after I smell it for the first time. My nose died.
Well, plus I was allergic to cats.
It is not easy to keep a pet.
So I lived with 3 cats, and I'm allergic to them. And my cat, one of the 2 sisters, my cat Gracie, she used to sleep on my face. I'd wake up with my eyes swollen shut. All right, so let's finish up the discussion with Swift here, and then we'll take a little break and then keep trucking. Okay, so we see ObjectiveC is this guy, Swift is that guy. They look very different, right? So now here's the kind of the punchline with that. We go back here to this guy. A lot of people here were saying, oh, well, Swift, long overdue. We've been sitting here on ObjectiveC for years and years and years and years. Finally, they helped these guys out with Swift.
Oh, now I recall it. You told me that there were too many Java programmers who couldn't shift to ObjectiveC, and then they did a Java kind of version.
Yeah, so these people were not complaining. If you're already drinking Apple's Kool-Aid, you're drinking Apple's Kool-Aid, right? Yeah. In fact, to this day, I prefer ObjectiveC over Swift. I just like ObjectiveC better. Swift is to appeal to the Java programmers and the C# programmers and to the web programmers. It looks a lot more like those languages than it looks like this. Now, having said that, though, if I've been an iPhone programmer for years since it came out. Even though I prefer ObjectiveC, if I start a new project today, I write it in Swift. You can choose. You don't have to write it in Swift. You can choose to use ObjectiveC, but the new stuff is all being built in Swift, so you might as well use it.
So ObjectiveC is still being supported by...
Oh, yeah. Yeah, it's still supported. Because there's a lot of projects out there that were written, like Uber, for example. Their whole application is written in ObjectiveC. So why would they want to rewrite that in Swift when they already have something that works? They can just make add-ons. And you can actually bolt on Swift updates to an ObjectiveC project.
Oh, you can do that.
Yeah, so you can, if they're going to take an existing class in the Uber application that's written in ObjectiveC, they have to, if they're updating that file, they have to update it with ObjectiveC. But if they want to create a new class, they can write that in Swift and have these guys talk to each other. So they can write new stuff in Swift if they want, but they don't. Yeah, Uber still uses Objective-C. It's
You said it. I think you training to the new Uber.
yeah. So I work for a place in New York called Thinkful. I run their enterprise training thing. So Uber is one of their clients. So when Uber hires a new iPhone or Android developer, there's like a 3-week training course that I take them through to learn the Uber way of writing iPhone stuff, that kind of crap. All right, so that's our history of languages, blah, blah, blah. Yeah, let me talk about arrays here real quick, and then we'll take our break, and then we'll come back and do our linked list stuff. Okay, so here I'm going to steal this. I don't like that kind of slide. All right. What class is that one? Do you know what class is going on down there?
555.
515 or 5.
Who's teaching it?
550. No, it is yesterday.
Oh, Hoppy.
I think no. I think 550 is yesterday class.
I was just wondering whose voice I was hearing. I didn't recognize it. What's up?
It's not male, it's female.
Is it? So then maybe they're giving presentations.
Maybe some teacher, because we have one that lady teacher.
Yeah, Spencer.
Yes.
Professor Spencer?
Lady Spencer.
Yeah, I would usually see her. I don't think it's her.
haven't had any class with her, but we had a conversation 1 or 2 times in the lab.
Yeah.
I feel a little bit he got more wordy on the things I was not able to understand.
Oh, he went into too much detail?
Too much, yeah, he read it from the slides too much.
Oh, I gotcha. So instead of like creating like real life examples.
Yeah, I was like.
I gotcha. You kind of got lost in the details.
Okay, this is what it is, and this is how we use applications and use it.
I gotcha. All right, so there's our new keyword. Tell me what that guy does again.
He finds an address and give it to the AI.
Yeah. Real estate agent gives us memory. That guy goes and finds us memory. So ultimately what gets stored in AR is some memory, and that memory is said to point to some place in memory. So effectively what this line of code right here does is it creates this structure. Okay? That is, it creates an array capable of holding 6 integer values, but there are no integer values yet. It's just a structure built for that. Kind of like if you went into Target and you bought like a shoe bench that you could put some shoes into, but it doesn't come with the shoes. All right? you got the shoe bench. Now, the bottom here, we index arrays So a 6-bucket array has legal buckets 0 to 5. All right, but up top here, I've written some memory addresses. I've written 100, then 104, then 108, then 112. Why do I jump by 4?
It is 4 bits.
4 bits, integer variable is 4 byte size.
4 bytes. 4 bytes, not bits, right? So we have our primitive types. Primitive types. We have byte, short, int, long, char, float, double, Boolean. So bytes are 8 bits, short are 16 bits, int is 32 bits, long is 64 bits, char is 16 bits unsigned, float is, let's see, I think it's 8.16. This guy is, actually no, it's 1632. Oop. This guy is 32.64. And then Boolean is 8 bits. Where's the byte? All right. So right here, an int is 32 bits or 4 bytes. Okay. Now, tell me, why are chars unsigned?
Because they don't store any integer number value. They don't need to be plus or minus. They store string values. And they're all, the strings or characters are like 65, 97.
Okay. So if we create a char, and I say char C is equal to the question mark, like that, what is actually stored inside of C? Yeah, not that address, the ASCII value. And actually in Java, it's the Unicode value. Unicode value. So we have ASCII versus Unicode. Do you know the difference between those guys?
The size 8 bits, 16 bits.
Yep. All right, so how many unique characters live in the ASCII character set?
256.
Okay. And how many unique characters live in Unicode?
65,526.
Where'd you learn that? Where did you learn that?
Yeah, I did a lot of study on these
All these by
databases, 2 database classes, last class.
Okay. So you talked about this in 535?
No, we were not.
Okay.
We were only given idea like primitive data types and operators. So that time I opened this Oracle documentation and I'm looking at all these things.
Yep. So a 16-bit number, this is 0 to 65,535. If we were dealing with a short, this guy, which is also 16 bits, but this is 16 bits signed. This is negative 32,768 to positive 32,767. You add those two together, absolute value, you get 65,536. Right. Yep, so Unicode, the first 256 characters of Unicode are ASCII. So Unicode is a superset of ASCII. Okay? So basically Unicode is ASCII plus all the rest of the world's characters or other languages, right? You know, we kind of, at the technology level, we decided that the world does not revolve around America.
So Unicode is like it stores some Chinese characters.
Oh, all the characters. Yeah, characters from your native language, they're all in Unicode. Yep, that's the purpose of Unicode. But the reality is the rest of the world just started speaking English because the dumb Americans wouldn't convert, right? I met a friend of mine. He's lived here for a while, but he's British, and his sister also British, but she lives and works in Tokyo, Japan. And she's been there, I think, for like 10 or 11 years. Doesn't know Japanese.
Nothing.
I mean, you know, a little bit.
Yeah.
But you would think after 10 or 11 years, you'd be maybe not completely fluent, but yeah, be able to get by, right? Nothing. Just, yeah, everybody just speaks English to me. It's fine.
Yeah, it's just even in India we have official language is English, so our documentation, our exams, and everything. So.
Well, right. But when you came over here, one of the things you wanted to do was practice English. So you wanted to speak English with other people, you know, which then becomes a challenge. Well, it becomes a challenge because when you're hanging out with your friends, you want to speak your native language, right? Because they speak it, so and it's easier for you, right? You know, if you're, you know, you're.
Arts and those things, it is easy to convert in. Like if we are speaking same language, you can simply express your emotions and thoughts with language.
Oh, plus you're just more comfortable with it.
Yeah.
I mean, you have a larger vocabulary.
Yeah, we have large.
You know, I might say stuff and maybe 95% of the stuff I say, you guys get. But every now and then I'll say a word or a sentence or something like that that you miss because it's not a familiar word to you. It's just, you know, same thing. If I'm speaking to somebody with a larger English vocabulary than me, then they might say a word that I don't understand. You know, like my wife, she doesn't know the names of almost any cheese.
Oh, gee.
Yeah, you know how there's a whole bunch of like crazy names for cheese?
Yeah.
She always has to ask me when she's looking at a menu, like, you know, what kind of cheese is that? Is that one of the funky cheeses? All right. So yeah, so chars are actually primitive types that hold a numeric value that maps to a Unicode value. All right. So because ints are 32 bits or 4 bytes, as we're walking through memory here, we take a 4-byte step.
Does I think base address into I?
Yep. So a couple things about arrays that are important. So arrays are contiguous memory. They require contiguous memory, which is a fancy way of saying memory in a row, memory next to each other. Okay? So we have this array AR, the new keyword returned for us the base address of that array, the beginning of the array. But then to get to a certain bucket in that array, we start at the base address and then we walk to a future place. So, for instance, AR at bucket 3, if I wanted to just do something like this, AR at bucket 3 is equal to a 7. AR at bucket 3 says, go to AR, add to it 3 times the size of, in this case, an int. So that's 100 plus 3 times 4, which is 112, which is where bucket 3 lives. That make sense? So that's how arrays are organized in memory. They're contiguous memory next to each other. Okay, so 2 things we want to remember about arrays. They're fast and they're memory inefficient. Because when we said, hey, I need a plot of land big enough to hold this many of those guys. So that means this real estate agent had to go out and find me 24 bits of memory next to each other. Right? So for a very large array, you could run into a situation where you have enough free memory for the array, but not enough memory next to each other for the array. Yep, that makes sense? So now realistically, we have a lot of memory in our computers today, so it's probably not going to be an issue, but still a thing. Well, what do you mean?
Like float-point calculations, if values of that big scientific calculations are stored in array, then it will be a problem.
You mean if you're calculating out to some like really far precision, and you're storing the decimal place values in Okay, yeah. So if you want to store pi up to 50,000 character, 50,000 digits or something, yeah, then now you're
And
well,
then predicting
the bigger footprint, right?
More problem is if it is like full and then you have to assign a new location and bigger than that, maybe that is not available.
Yeah. Yeah, realistically, if you wanted to store pi to a whole bunch of digits, you would probably store it as characters. You would do the math, but store the actual digits as characters, because a char is only 2 bytes, so it's got a smaller footprint.
I kind of happened to get a error message saying array index out of bounds.
That means you walked off the end of an array. So you would get a array index out of bounds error if you did something like this.
I just tried to open multiple games at one time, and that happened. I didn't understand that.
Oh, well, I would have to see the exact scenario, but that array index out of bounds error you would get from this right here. I tried to access bucket 7 of AR when 7 doesn't exist. I've walked off the end of the array. That makes sense?
So in this case, we have to define another array and then move the stuff.
Yeah, so in Java, if you have an array of 6 things, you need to store a 7th thing, you have to, so if we're going to put this in a real life example, let's say you built a house and you decide you want to put a porch on your house. Well, in real life, we just go outside and build a porch, right? That's not how Java would work. That's not how our modern programming languages would work, because our house is the exact correct size for what we have.
We don't have land.
So if you want a porch, then what you got to do is you got to go find another plot of land that's big enough for your current house plus a porch. You then rebuild your house over there and then build the porch. Make sense?
Makes sense,
Yeah, it's memory inefficient, this guy right here.
Yeah.
All right. So let's take a few minutes. We're going to come back and we're going to talk about linked lists. And we're going to start writing those guys. So why don't we take a 10-minute break?
Yep. I'm going to grab a coffee. Do you need this soda?
No, I'm good.